Hello and welcome back everyone. Welcome to yet another video in this playlist that is data analytics project. Today's project is all about La Liga. Now if you are into football just like me, I hope that you know about La Liga. That is the second most famous, most watched league around the world as far as the football is concerned. That is after EPL, that is English Premier League. Now this particular project, it is, we are trying to understand that how does different things like xga, formation, position, head to head, wins or head to head records between the two teams, and goal scored, goal assist, number of shots made in a game, how all these things actually help us to predict the outcome of a certain match. Now if you have been watching the football, you must have seen some of the things that I'm mentioning here. That is the head to head score, what is head to head record of the two teams, and what is the xg, what is xga of certain team, and how it actually affects the outcome of any match. So this is what we are trying to do. Now it is a data analytics project per se, but we'll be using machine learning techniques as well to actually help us understand what are the parameters that are going to be helpful for us. With that, let us get going and see what the project is all about. Alright, so you can see that I have created a folder on my computer and I have placed this CSV file in that folder. Now in the same folder, I would create a notebook. I'm going to quickly call that as 01 or just simply La Liga project. So let me start with importing the required libraries. I'll be starting with importing the NumPy. Import Pandas as PD. So NumPy and Pandas will handle the dataset and numerical computation. Then I will import from sklearn.ensemble import random forest classifier. So this is the only algorithm that I'll be using for this particular project. Then I'll say from sklearn.model selection, I'll say import grid search CV and also time series split. And then for performance evaluation, I'll import from sklearn.metrics accuracy score. I'll import confusion matrix, and I'll also import precision score. Okay, lastly, let me import the libraries for visualization. I'll say matplotlib.pyplot as PLT, and I'll import Seaborn as SNS. Again, just to be clear, random forest classifier, it's a machine learning model used for prediction due to ability to handle complex non-linear relationships in sports data. Perhaps the most common machine learning algorithm that you will use in sports science. Then you have grid search. Again, requires no introduction. It is used for hyperparameter tuning, and then time-based cross-validation, ensuring robust model evaluation. Lastly, you have all these things that is for evaluating the model performance, and these are to communicate the results effectively. Now I'll import the dataset. I'll say df, or rather matches, is equal to pd.read_csv, and pass in the name of the file, which happens to be matches.full.csv. And I'll if you just run this as it is, so you will see that it is having this 0 as one of the column, unnamed column. So I will intentionally mention that my index column, it has been provided to me and it is at 0. or you can just simply drop the unnamed column as well. That depends on you. I'm taking that as an index column. So if you run that, you can see here that this is now my index column. So it is loading the La Liga match dataset from a CSV file, assuming that first column is your index. So it is going to drop the first column, which is often an unnecessary index column. All right. So you can see here that this is the dataset that you have. You can see the date of the match, perhaps the time. The competition is La Liga. What is the match week? When? What was the day of the week here? And the venue, whether it was home or away. Then home of away of the team that are concerned with. For example, Barcelona here. Then the season and many other things here. Right. So not all of them are imported for us. That are 28 columns. So various characteristics, but the thing that is going to be useful for me is to just keep track of the column types. That is matches dot info. When you run that, you can see all of them. Well, not all of them, but really the date here, it is string, time is string, and so many other things. So I have to fix all these columns first, and that is the reason that I have not gone into the too much of the detail of the columns, because we'll be fixing them anyway. All right, so first thing that I have to fix is the date column. So let me see that. So matches date, you can see that it is a object, thereby it's a string. Basically, if you grab any of it, you will see that it's a well, not actually, you can run this and you can see here that it is a date. All right, so the point is we have to do something about it. I'll say that take my matches.dates and cast it pd to underscore date time, and there we go. Now run that, and you can see here that the data type is now date time. So this I'm going to assign back to date. All right, okay, great. So the next thing that is going to be important for me is this venue. If you look at this particular column here, that is matches, then venue, you will see it is kind of home and away. So what I'm going to do here is I'm going to convert this as category. I'll say as type as category. All right, and you run that, you can see that there are two categories, home and away. And if I just take this here and say cat dot quotes, then you have basically converted that home and away as numerical coding, because understand that your machine learning algorithm, it does not understand the string, it does not understand the letter, it can only understand the digits. So thereby you have to, as we call it, that is, you have to perform feature engineering on this, and thereby we have converted that to 0 and 1. So the 0 means it is away, 1 means it is home. So this is going to be I'll create a new column itself. This is going to be matches and venue code. Okay, so this is one another column. In fact, what I will do is I'll mention here specifically that what we are doing here, it is actually feature engineering. So next is same thing but for opponent, right? Because if you see the matches here and say opponent, you can see it is Valencia, Athletic Madrid, and so on and so forth. So what I'm going to do again, I'm going to convert that into category as well and convert that into code. Thereby if you run that, you'll have all these opponents here, right? So ranging from 0 to all the way to 24. This is my same thing, but just one change. This is not opponent, but this is opponent code. So every opponent I basically coded it out. Why? Again, because for the very simple reason, my algorithm, it does not understand strings, it does not understand letter. Everything has to be numerically coded. Then we can see here that we have the time here as one of the column. So what I'm going to do here, if you take a look at the time, you will see you have all this time here, but you can notice that it is the object, it's a string. So what I'm going to do is I'm going to say that split on this this column here, and if you run that, you will get this kind of list for all of it. Once you have gotten the list, I'm going to take the string of it again and then grab the 0. If you run that, you will see that I have taken out the hour from my time. So what is this? This is as type integer, and this is matches. Basically, you have taken out the hour from your time column. All right, you run that, and there we go. So this is yet another column that you're having. Next is to get the day code as well, because if you see the day of the week here, in this case, sorry, rather the date here, it is going to give the same thing, because the date, if it is time, if you're converted into date time, you can basically take out the day out of it. So it is kind of a duplication of information here. But anyway, I'm going to say matches, then take the date, and if you run that, you can see all you have all is all these dates here. Then I'm going to say this is dt dot day of week, and you run that, you can see that you have basically coded out all the days. So this numbers are basically 0 to 7 from Sunday to Saturday. So this is, I'm going to assign this as in fact it can be not 0 to Saturday. Let me check this one more time. So this is not date, this is day, if I'm not wrong. There you go. So Tuesday here, it is 1. So your Monday is 0, Monday, and then 1 is Tuesday, Wednesday is 2, then Thursday is 3, then so on and so forth. So this is what? This is matches day underscore code. Next is the referee that we have to talk about. So referee, there are a bunch of referees in La Liga. If you run that, you have all these names here, bunch of NNs here as well. But what I'm going to do is simply going to take the category of this as well. So I will copy this and paste here. There you go. Right. So you're getting all this reference. No need to take care of this -1. This is, I'll take it that it's a missing value. Right. So this is your referee code. Referee code. Okay. Similarly, we'll take the captains as well. You can see captain. It is all these people here. I'll do the same thing. I'll copy and paste here. Right. So this is captain underscore code. Okay, so one more thing that you have is the XG and XGA. So XG is basically expected goals and expected goals against, that is XGA. So what I'm going to do is I'm going to create a new feature which will be a difference matches of XG minus matches XGA. There you go. So you have this difference between the expected goal and expected goals against. So this is matches, then XG difference. So this is what you're getting in again, there's a difference between the xg and xg goals again. Now we have one column that is SOT. Unfortunately, this is SOT here. This is shots on target, and then you have SH as well. This is total shots. So what I'm going to do is I'm going to divide SOT with SH. I'm going to divide shots on target by total shots. That will give me shot accuracy. So I'll say matches shot accuracy is equal to matches. This is xg. Sorry, not xg, SOT divided by matches, and this is SH. But if you see here that matches tell me that how many times there are 0, and you can see here that there are some zeros here. So what I'm going to do is for SH, that is total shots, I'm going to replace this. I'll replace 0 comma np.nn. Why? Because I do not want it to be divided by 0, otherwise it will be infinity, right? So for that I'm going to convert that as np.nn, or simply you can just replace this as 1 as well. I'm by default I'm saying that if there's at least one shot on target, sorry, there's at least one total shot in the entire game. Although there are matches that where teams they are not able to put even one shot away, so that is there, but still I'm just going to put that as 1. Now if you check the shot accuracy here, alright, and run that, you are getting all these values here. Now just to be on safe side, what I'm going to do is I'm going to say fill NA. If I'm getting 0, although there's highly unlikely that you'll get a 0, but if there's a 0, if there's a NA, I'm going to fill that as 0 just to be on safe side. And I'm going to take this one more time and assign this back to shot accuracy. Next is to round, because if you see the table here, this is match week 1, match week 2, match week 3, and so on and so forth. So what I'm going to do is same thing, matches round, and then take this entire thing, put it over here, run that. You can see that it is going from 0 to all the way down here. So this is matches round equal to, this is round code that you have. Next is matches, then you have a column that is formation. Do we have here? It is not visible, but if you pass in the formation here, you can see you have different kinds of formation. So that can also have a say in the your match as well. So again, I'm going to put that into I'm going to put that as category and get the category codes. Take this entire thing and put it over here. Run that. You can see you have different kinds of formation here, which is I'm going to assign this to matches form. Just take form code. Then you have the oppositions formation as well. Opposition formation. You can see that this is what you're getting. I'm going to take this here and say dot as type category dot cat dot codes. So this is, I'll take it and assign this back to here, and this is opposition form code. And lastly, I have matches, then you have result, and that is just wins and losses. So I'm saying basically wherever I'm getting win, I'm going to assign that as type integer. There you go. So you have 1 and 0. 1 represents win, 0 represents losses. So this matches, then target. Alright, again, just to be clear, what we have done here in this entire feature engineering section, it is we have converted the date column to a date time format for a time based operation. We have encoded the categorical variable, that is venue, opponent, referee, captain, round, formation, opposition formation, into some sort of numerical codes using cat doc codes for machine learning compatibility. Then we have also extracted day of the week from the day column here, date column rather. Then we created the new feature XG difference, that is difference between expected goals and expected goals against, that is XGA. Shot accuracy, it is shot on target divided by total shots, handling the division by 0 as well. Then we have defined the target variable here. If the team wins, that is W, that is going to be 1, otherwise it is going to be a 0. That 0 or also includes the draw as well. So I am only concerned with the win, not win, that's it. Why it is done, I'll repeat that as well. The machine learning model require numerical input, so categorical variables are encoded. XG difference, it captures teams offensive and defensive quality in a single metric, which is often predictive for match outcomes. And shot accuracy here, it captures shooting efficiency, a key performance indicator in football. Then we have extracted the hour and day code as well, that because that accounts for potential effect of that match timing, that is evening games, weekend games, and all that. Then we have the binary target, simply predicting the wins, making it easier to evaluate and predict the outcome of the future. Next is I'm going to talk about rolling averages. Rolling averages require, basically it captures a team's recent performance trend. Example, average goals that are scored in last 3 matches, which are more predictive than a single match states. So let us do that. I'm going to create a function that is going to be rolling underscore averages, and that is going to take in the group, comma, columns, new columns rather, and then I'm going to say group is equal to group dot sort values, that is going to be date here, and rolling stats that I'm concerned with, this is going to be group calls dot rolling 3 closed equal to left dot mean. Then I'll say group new calls is equal to rolling stats, and you return group dot drop na. Then I'll say subset is equal to new calls. Alright, so let me explain what this is doing. It is defining a function rolling averages to compute 3 match rolling average for specified columns. So because I have to mention the column that I'm concerned with, that is goal for, goal against, etc., each within teams matches, sorted by the date here. So I'll say that the columns that I'm concerned with, I'll say matches dot columns. You see that I have all these relevant columns here. So what are the columns that are going to be useful for me? I'll say calls is equal to all the relevant columns, and I'll start from here. Goal for, goal against, copy this, create a list, paste here. Then I'll say I think we have to take sh as well, if it is available somewhere. Yeah, sh, sot, I'll say distance. Then we'll say fk, pk attribute. That's it. I'll copy this, all these things here, paste here, and then I will also take the position stat as well. There we go. And that's it, I believe. No, I'll take shot accuracy as well and xg difference as well. So shot accuracy is here and xg difference is here. So I'll copy this as well, copy and paste. So these are the columns that I'm taking into consideration. Then I will say that for C in columns, I want to create a list comprehension that is going to be f literal curly braces C underscore rolling, and that should give me, if I run that, yeah, this is giving me all this value here, which is the new column. So we have to still do the group by, and that is going to be for a team, and then dot apply lambda value, and that is going to be the function that I've created, rolling averages. That is going to take the x here, columns, comma, new columns. If you run that, let me check that if it's working. No, it is not, because I'm getting the error that says xg not in index. That is because I have forgot the comma here. So you have to put a comma and run that one more time. There we go. So you can see that for every time I got the date, time, competition, round, and all those things. So for all the different teams, I am able to do that. So this I'm going to assign to matches rolling. Next is I will take the matches rolling and I will drop a label, dropping the team as an index. So if you run that, you are just left with the other column here, and the team is dropped. This is I'm going to assign back to, and then if I say matches rolling dot shape, pass in 0, you have this, which is going to be, if I put that into the range, this is matches underscore rolling dot index. Okay, so next is to create a new feature from last 5 matches. New feature, that is team form, how my team is performing in the last 5 matches. And that also again, it is basically it is going to capture a new team's momentum more directly than rolling averages of stats like goals. A 5 match window, if you choose to balance the short term trends with sufficient data. So points based form, it is a standard metric in football for assessing the team performance, so that it becomes much more intuitive for audience. Now let me create def calculate team form. It is going to take the group, and that if I say group dot sort values based on the date, because most recent means we have to take the latest of the 5 matches only. So that I'm going to assign this back to the group. Then group has result dot map. This is I'm saying win, put that to 3, and losses, put that to 0, and this is 0, and then the draw, that would be 1. And this entire thing, it should go in the dictionary actually, and I forgot about that. So this is a dictionary that I have created. Right, then this is what? Group comma points. Next is group points dot rolling, then 5 comma closed equal to left. Then I'll say dot mean dot fill inning. Let me just put this into group again. Group and team form. Right, so this is the thing that I'll be returning, that is return the group. Right, so this is actually this new feature. It is capturing a team's recent momentum that is based on the last 5 window that is over here, and it enhances the original model by adding a direct measure of the recent success, and that will hopefully improve the prediction accuracy. Alright, so this is what we are doing here. Next is to create one more feature, that is head-to-head win percentage, that is not being given, and I can tell you that this is the last feature that we'll be creating. I'll say copy and paste here, and this is going to be head-to-head win percentage. Alright, so this is, there we go, and I'll say def calculate head to head, and it is going to take the df here, any data frame, and I'll say head to head is equal to df dot group by, which is going to take 2 things. One is the team and another one is the opponent. You can check back and see the data frame yourself. You should find 2 columns, that is team and opponent, and then I want to get the target out of it. Target dot mean dot reset index. Then head to head columns is equal to 3 things. One is going to be the team, second one is opponent, and third one is head to head win percentage. Return then df dot merge. I want to merge df with h to h, the new that I've created, on team and opponent. Alright, and I'll also mention how is equal to left. There you go. Now let me run the first one here, the rolling average here. That is, I'll say take the matches rolling and do a group by on team. Alright, and this I will apply the calculate team form, and if you run that, okay, I'll get an error that says must specify a fill value or method. Yeah, so fill value, fill NA here, it should be 0 only, then it will work. There you go. So you are able to do the group by here, the same thing that I've done here, really no difference at all. So I'll take this, right, and put it over here, and the next thing is also the same. I'll copy everything here. There we go. Okay, so we have got the team form in this case. Next is to do the same thing for head-to-head win percentage as well. So I'll say the matches rolling that I've created, I want to pass that into calculate head-to-head, and then pass in matches rolling. Okay, it has given me error one more time. Let me check this. Team and opponent is the key error. Absolutely, this has to be 2 different things. Run this one more time. There we go. It is perfectly fine. Now this is my matches rolling for this one, which I want to take here and grab the head to head underscore win underscore pct, say dot fill na 0. Alright, so this is what we got. Now this is the new column that I have created. So I'll take this, assign this back to this. You see, this is what we got, and run that. Okay, there's some error, head to head win percentage. Yeah, absolutely, because we actually have already filled the NA for this. The only solution for this when you get this kind of issue is to run all the cells. There you go. Now it is working fine. Right now, again, what we have done is we have created the historical win percentage of each team against the opponent using this feature head to head win percentage here. So if you check the matches rolling, you will see that you have created head to head win percentage. Okay, again, these are the percentage, 33%, 22%, and all that, right? So we have created that. Why? Again, because head to head performance is critical in football, because as some teams consistently outperform specific opponents due to psychological factor, historical factors, and all that. So this feature add context that rolling averages or single match stats they actually miss. All right, now let me go into the predictor, predictions, and train test split, rather predictors actually. Now I want to take the columns which are only important for me. First things first, new columns. These are all these things, the rolling factors. And besides, I want to take the columns which are only important for me. So from the our original data set, which was matches dot columns, I will take only few of the columns here which are going to be important for me. So this is going to be venue code, opponent code, hour, day code, referee code, captain code, XG, basically whatever I have created as a part of this particular project. I am going to take only those. So this I'll put that in a list, and I will concatenate with new columns. There you go. I'll add one more thing, that is the two extra features that I've created. One is the team form. If you remember, team form here, which is what I'm going to take and put it over here, and I will take head to head win percentage. Okay, so this is the columns that I am worried about. So these are my predictors basically. Right, next is to separate out my dataset. So for that, I'll say my train value is matches rolling. Then I want to take the date less than 2025 0101, and this is I'm going to put into the matches rolling over here. So every match before this particular year, I'm going to, that is 2025, at the point of recording this video, I'm putting that into the training set, and every match that is conducted from 1st January onwards, I'm going to put that into a training set. Next is to create the model, and I'll be straight away going to the grid search. So I'll say param grid, that is going to take all the parameter grid for random forest classifier model, and that I'm going to select as 1 n underscore estimator. Again, if you're not sure about this, you can just pass in the random forest classifier and then do a shift tab, and there you can see an estimators here. This is what I'm going to take, and I will take maximum depth here, and min sample split is also something that I'll take, right? So you can pass in multiple values here. So n estimator I'm taking first. So n estimators is equal to, I'll take two estimator, one is 100 and 200. Then I will say max depth is equal to, sorry, this is a dictionary, so I have to pass a column. Then max depth I'm passing as 10 comma 20. Then I will say minimum samples, I'll actually have to do a copy paste this time. Minimum sample split, if I'm not wrong, here. Okay, so we have this minimum sample split. This is a list again of 5 comma 10. Right, so this is the parameter grid. Let me create the base model. So random forest rf equal to random forest classifier. I'll set some random state, any number, you can choose any other number as well. And then I'll say grid search CV, take the base model, take the parameter grid. CV is equal to time series split, and number of splits is equal to 2 in this case. I'll also define the scoring. This is precision. I'll explain everything, just give me a second. Precision and n underscore jobs is equal to 1. This is grid search that you got. Then I'll say grid search dot fit and train predictors. Then this is the first thing that we got, and you have to pass in, actually this has to be just one list only. Alright, so just remove one square bracket and then comma train target. Okay, then run that. Hopefully this works. There you go. Now if you check the grid search and look for best estimator, you can see these are what you're getting. So this is my is going to be my best RF. Now what we have done, basically we have defined a parameter grid for random forest model, an estimator, maximum depth and minimum sample split using a grid search CV with time series split, that is threefold. We have used to find the best parameter, optimizing for precision basically. And for that, let me check whether we have installed precision. Yeah, we have installed. Imported the precision, and then we have trained the model with best parameter, that is best RF that we've got. So hyperparameter tuning improves model performance by finding the optimal configuration for the random forest. Time series split, it is ensuring the cross validation respects the kind of temporal order of matches, preventing future data from influencing the past result. Since we are obviously dealing with a real world data set, we have to take care of that as well. Then optimizing for precision and not accuracy, it will prioritize correctly predicting the wins, because we are only concerned with the wins and not wins, right? We are not concerned with the draws, we are only here for the wins. So which is obviously much more, if I have to be honest, much more relevant for the football betting or analysis than overall accuracy. So this is an improvement over here over all other models that you can find elsewhere. Then I want to go into the evaluation. So I'll say take the model best RF and say predict test only the columns in question, that is predictors. Run that, you're getting bunch of zeros. Again, 1 is for win, 0 is for not win. That includes draws as well. So preds is equal to this. Then I'll check the accuracy. So accuracy score, I'm getting test the target, that is the true value, whether it is win or not a win. And this is pred. So we are getting accuracy score of 1, that is brilliant, but I don't think that should be the case. Okay, let me check the precision score as well. precision score is test target, then Brits. Okay, it is also 1, which is not good actually, because this cannot happen. Let me check this one more time. Yeah, this should be -1 here. Okay, let me run all the cells. Hopefully I'll get a better result now. Nope. Let me check if there are some more things that I'm missing. Okay, so after struggling a bit, I am finally able to see what the issue was. Actually, we have included a target in the predictors itself. Thereby, I have to remove this, because if you're including the target, the one that you're trying to predict, if you're including that in the predictors, then obviously you are going to get the 100% accuracy. So I have removed this. Now I'm going to run all the cells one more time. There we go. Now I'm getting much more realistic result here. So there we go. We are getting about 77% accuracy. But let me see what are the important features in this random forest model, so that I can focus only on those feature only. So I'll say plt.figure and I'll say fixed size. Fixed size is 10 by 6. And I'll say sns.bar plot. I'll plot out x equal to best rf dot and y is equal to predictors. And I'll say plt dot title feature importance in a random model. And lastly, I'll say plt dot show. Run that. There we go. So these are all the features that you can see here. Very interestingly, head-to-head win percentage is really one of the most important feature. Okay, so and that is why that, if you have ever seen the matches on Sky Sports or whatever, you must have seen that they really focus on head-to-head win percentage. And in modern days, they are focusing on xg values as well. So xg difference is also going to matter a lot, and then shot accuracy and other things as well.